Hey, good morning, everybody. Not good morning, good evening. Hello. We're going to review systems here to get ready for your exam, and we're going to take a look at all the different methods. I'm talking about the graphing method, substitution method, and elimination method. All right. And also, I'm going to kick in the KEY2018 and do it that way too. I would highly suggest you take out your notes. All right, on all those different methods. We're in chapter 6. This is all over chapter 6. So take out, all right, your chapter 6 notes. Okay, on systems, you have them. All right, and use them, of course. Also, check remind. The reason why is because I sent out my videos, my video hyperlinks. So if you need to review a lesson and you need a good resource, well, then go into your chapter, section 6.1, 6.2. This is a graphing method here. 6.1 was graphing method, 6.2 sub method, and 6.3 that was elimination method, and double elimination was 6.3b. So you have the ability to take out your notes and use them. I would highly suggest that. You also can use my hyperlinks. Check remind, I sent everything. You can also go to my YouTube channel. All right, go to the YouTube channel and look in the folder, the Algebra 1 folder, and everything we've done in the entire year is up there. Okay, I'm surprised more people haven't figured that out. Okay, you can access it anywhere in the world. All right, so let's get started. Here we go. Let's solve the system. You can use intercepts or you can solve for y, either way. Okay, use either intercept method okay, or solve for y, okay, to get in slope intercept form. Okay, all of these we've done before, so nothing new. Okay, we've been doing it every day for the last month in respect to the graphing method through linear programming. All right, so here we go. Let's add the opposite. Okay, this is not the intercept method is solving for y. You get negative 6y is equal to negative 5x plus a negative 32 or minus 32. Divide by 6, divide by negative 6. And you get y is equal to 5/6x. All right, minus, let me see, 32 divided by 6, and that divides 5 times, remainder 2. All right, 5 and 2, 6, or 5 and 1/3. There's your slope, and there's your y-intercept. That's equation 1. Next one, you solve for y again, and you get 2y, okay, is equal to negative x plus 16. Divide everything by 2. And what do you get? You get y is equal to negative 1/2 x plus 8. There's your slope, and there's your y-intercept. Okay, so here we go. Start at negative 5 and 1/3. Excuse me, not negative, positive. A negative divided by a negative is a positive. Fix that. Positive 5 and 1/3. All right, going a little bit too fast. So start at 5 and 1/3. Break up the unit into thirds. Notice I broke it up into 3 equal parts. Okay, and right there is 5 and 1/3. Now you got to go down, or excuse me, go up 5 and right 6. Okay, but you're off the grid. All right, so let's reverse that. Let's go down 5 and left 6. So down 5. So 1, 2, 3, 4, 5, right 6. 1, 2, 3, 4, 5, 6, right here. And then so we have 2 points. So let's graph your line. If you want to repeat that, you can, by the way. So something interesting is going to happen with this example here, and I'll talk about it here in a minute. So this is not exact because the graphing method is never exact, but it's close. All right, next line. So start at 8, all right, and then go down 1, okay, right 2 on the negative 1/2. So down right 2, ooh, there's the intersection. Down 1 right 2, down 1 right 2, step it out, okay, and then draw your line. It's not the most accurate method in the world. That's why they invented algebraic methods like the substitution method, which we're going to talk about, and we're going to talk about the elimination method. But it's pretty accurate. So all you do is read your intersection point, and guess what? That's 2, 7. So 2, 7 is our solution. And we'll check that at the end too. All right, so there's your first one. Now, if you solve it using the substitution method or elimination method, you better get the same and xy values, okay? You better get x equals 2 and y equals 7. If you don't, then you made a mistake, okay? So once again, this is section 6.2, this is section 6.3, okay, and 6.3b on the double elimination method, all right? So see your notes. Be smart, be wise, and be a good student. All right, find your notes. You took them for a reason, right? So use them. All right, so let's go for it. Let's do it by the substitution method first. Well, the first step is to isolate the variable. So isolate, okay, a variable. And notice I didn't say isolate x. I didn't say isolate y. I said isolate a variable. You know, pick the easiest one to isolate. That's your first step. So to isolate x here, you got to add 6y and divide by 5. 2 steps. To isolate y, you got to subtract 5x and divide by -6. 2 steps. Over here, if I just subtract 2y, okay, I can do it in 1 step. So, and no fractions, by the way. All right, so the best thing to do is to isolate x here. Pick the one with the single coefficient, okay, with a coefficient of 1. That variable right there. Pick the easiest one to isolate is what I'm saying. So what do you get? Well, you get x is equal to -2y plus 16. 16 there. Okay, well, x is isolated right there, so you take whatever x is and you substitute it in. All right? And then what do you get? Well, let's see. 5 times x is -2y plus 16. There's my substitution, -6y equals -32. Let me highlight it. I just substituted in for x right there. Okay, distributing through, you get -10y plus 5 times 16 is 50 and 30 is 80. -6y is equal to -32. Adding like terms right here, I get -16y plus 80 is equal to -32. Subtract 80. I get -16y is equal to -112 right here. And you could use a calculator if you want. Divide by -16. You're going to get y equals positive something. I don't know. Negative, the negatives cancel, obviously. So 112, all right, divided by 16. That gives you 7. So y is 7. Once you know y, you got to find x, obviously. By the way, you would know you're right, because look, y is 7 right here. So obviously check your work as you go. And you take this back in and you substitute back. So x is equal to -2. Let me separate my work here so I can see things better. So x is equal to -2 times y, so -2 times 7. Notice that I just substituted in right there, plus 16. So x is equal to -14 plus 16, or x is equal to 2. So my solution is 2, 7 again. Okay, so there's the first one. And by the way, it's correct. 2, 7 is correct because I just solved it 2 different ways and I got the same result. Okay, I don't care what method you use. You better get the same result. I mean, just use your common sense. Okay, now you can eliminate the x's or the y's. I'm going to eliminate the x's. Okay, just for a choice there. Okay, I choose that. You can choose either one. To do that, you got to create opposites. If you go back and look at your lesson and watch a video too on section 6.3 or 6.3b, that's what we did. We created opposites. Opposite of 5x, let's highlight it, is -5x. So all I have to do is multiply this by -5 on both sides and write the result. Okay, so let's write it. So I get -5x here. -5 times 2y is -10y. and negative 5 times 16 is negative 80. Add, and you get negative 16y equals negative 112. Oh my God, I've seen that before. All right, divide by negative 16, and you get y equals 7. That's all you do, and then you plug this back in here. All right, and x plus 2 times 7 equals 16. I just used the same equation, okay, or one of the original equations there, and I get x plus 14 equals 16, and if you just use your head here, 2 plus 14 equals 16, so x is 2. And so I get a solution of 2 comma 7. And notice that I'm getting the same result everywhere, no matter what method I'm using here. I mean, just look at it right here, guys. No matter what method I choose, whether I choose the graphing method, substitution method, or the elimination method, it's all the same thing, right? One method backs up the other. The graphing method is only good if it's easy, and because sometimes it's or most of the time it's fractional, and you don't really know what it is. So you do it algebraically, either by using substitution or elimination. Okay. And then you got to check your result, right? Okay, so we got to check and verify that 2 comma 7 is the actual answer. So I got to substitute it in. So 5 times 2 minus 6 times 7, does that equal negative 32? Put a question mark there. Well, 10 minus 42. If you keep on simplifying, I get the left side negative 32. I get the right side negative 32. And I know I'm good, okay? Because that's obviously a true statement here. Okay, so the next one here, I'm going to write it over here just so I can have a little bit more room. All right, I'm going to substitute it in. So 2 plus 2 times y is 7. Just look right here and look in the ordered pair. Does that equal 16? Well, 2 plus 14, does that equal 16? The answer is obviously yes. So it checked out on both. So this tells me that 2 comma 7 is a solution to the system. Why? Because it satisfied both equations. Satisfied both, not one, but both equations. That's how you know. Okay, so highlight this. This is the reason why. It didn't satisfy one, it satisfied both. Both ended up being true statements, and that's how I know that 2 comma 7 is the solution. And that, my friends, is going to be on the test on Friday, okay? You're going to have to know all 3 methods. All right? So let's get good. Let's do it again. All right, so here we go. On this one here, I'm going to use intercepts. Okay, the other one I'm going to isolate y. So I'm going to use intercepts here just to change things up to show different techniques. All right, when x equals 0, this term's canceled out, and you get negative y equals 1, and that means y equals negative 1. There's your y-intercept right there. And the other one, so what is x when y is 0? Well, you put 0 in right here, and you get 2x equals 1. Well, let me see, 2x equals 1. That means x is equal to 1/2. So those are my intercepts right there. Now, if you don't like that method, okay, no big deal. You can take it down here and you go, okay, 2x minus y equals 1. Let me see, I'm going to add y, and I get 2x equals 1 plus y, then subtract 1, and I get 2x minus 1 equals y, or y equals 2x minus 1. So there's your slope, and there's a y-intercept. So watch this. If you plot 0 comma negative 1, you're here. You plot negative 1/2 comma 0, you're right here. Okay. Both, and if you connect your line here, you get this line going through them. Or you can start at negative 1 and use a slope. Go up 2, right 1. Go up 2, right 1. Up 2, right 1. Up 2, right 1. And I bet all these points line up. Okay? Just check it out. Take out a straight edge. Be accurate. And you're good to go. Okay, so there we go. Right there. So there's the first equation. Second equation, let's see here. Let's isolate y. So let's add 6x. Now you get 5y equals 6x plus 3 divided by 5. Okay, get y is equal to 6/5 x plus 3/5. Okay, so let's plot. So 3/5 is right. That's a little bit more than half, right? Half of 5 is 2.5. So 3/5 has got to be more than half. So let's go to a little bit more than half. And then go up 6, right 5. So up 6. So 1, 2, 3, 4, 5, 6, right 5. 1, 2, 3, 4, 5. And then connect. I'm not doing anything different than before. The only thing I'm doing, I got to adjust this line right here. Let's see if that's okay. That's close. That's close. Okay, so what is the solution right here? It looks like they're intersecting in here, right? So it looks like 2, 3. I don't know. I'm not sure because that wasn't very exact. Okay, so I'm going to put a question mark there. We'll have to check that. Not quite sure. Graphing method is not the greatest. Okay, that's why they invented substitution method, all right, and elimination method, which are algebraic methods. Because I don't know if 2, 3 is right. It could be fractional. Who knows? Let's find out. Okay, so here we go. Substitution method. Let's isolate this y variable here because it's going to be the easiest. Don't isolate x because it's going to cause fractions. On the second equation, if you isolate x or y, you're going to have fractions. Don't do it. Isolate, okay, the y variable first. Isolate y. So let's subtract 2x. No, I'm going to do it differently. I'm going to add the y. Okay, and I get 2x is equal to 1 plus y, and then I'm going to subtract 1. This is going to be easier. So I get 2x minus 1 equals y, or y equals 2x minus 1. So there's my slope, and there's my y-intercept. No, I don't have to graph that. I'm sorry. Okay, so it doesn't matter. I'm thinking graphing. Okay, so now I isolated y, and I got to substitute it in for y. Hence the name substitution. They don't call it that for nothing, guys. So negative 6x plus 5 times your substitution, right? 2x minus 1, and that's got to be equal to 3. So notice that I took y and I substituted in. Y is equal to 2x minus 1, so I replaced it. All right, it's called substitution or replacement, either one. Distributing through twice, you get negative 6x plus 10x minus 5 equals 3. Got to add like terms. 10 minus 6 is usually 4, so 4x minus 5 is equal to 3. Add the opposite. You get 4x equals 8, and obviously x is 2 because 4 times 2 is 8. So then you take whatever x is equal to and you substitute it in to find y. So what do you get? 2 times 2 minus 1 equals y. So 4 minus 1 is 3, and so 3 equals y. So I have my solution now. So 2, 3 is my algebraic solution. Okay? And guess what? Let's look up top. 2, 3, x is 2, y is 3. Notice it matches. Okay? And it better. Because if it doesn't, then you made a mistake. All right, now, elimination method, you got to create opposites. So how do you do that? Well, let's see here. You can, you want the opposite of negative 6, which is positive 6. So I'm just have to multiply this one by 3. It's actually pretty easy. So I get 6x minus 3y equals 3. So let's line them up. 6x minus 3y equals 3. Okay, add the equations. So 5 minus 3 is 2. So 2y is equal to 6. Y is equal to 2. Excuse me, 3. 2 times 3 is 6, guys. Okay, and then you got to find x. So what you do is you just take this guy and substitute it in, as I keep on talking about. So here we go. So we have 6x minus 3 times 3. Notice that I just put in 3 for y right there. Okay, and that equals 3. So 6x minus 9 equals 3. Add the opposite. 6x equals 12, and obviously x is 2. So my answer is 2 comma 3. There's my solution. So once again, I solve it a different way but get the same result, because it does not matter which method you use. Okay, it's going to give you the same result. So what I need to do is verify it. So I'm going to take this and I'm going to verify it, and I got to substitute it into both equations. Look at this, the keyword both. So 2 times 2 minus 3, does that equal 1? Well, of course it does, because 4 minus 3 equals 1. So that's good. And then negative 6 times 2 plus 5 times y. Y is 3. Y is 3 here. Does that equal 3? Question mark. I don't know. Negative 12 plus 15, does that equal 3? And the answer is yes. And so this one's good. This one's good. And so that tells me that 2 comma 3 is a solution to the system. There we go. And I just reviewed the entire chapter. The only thing I haven't done, and I need to, let's go back here and let's use a calculator here. I forgot to do that. Let's hit, let's clear this. Let's hit y equals and let's enter the functions in. Okay. Okay. Now, one of the functions is right here. Y equals 2x minus 1. So 2x minus 1. All right, next one, go down. Look how easy this is. 6 divided by 5, hit x, plus 3 divided by 5. I mean, anybody could enter this equation in, guys, as long as you have the equation in slope-intercept form. I'm talking about this one, and I'm talking about this one. They must be in slope-intercept form for the calculator, for the TI-84. Okay, remember that. Okay, so, and then go zoom 6. All right, and I'll graph them for you. So remember zoom 6. Oh, by the way, look at lesson 6.1b for this. 6-1b, it has all the steps, and I gave you the calculator steps too. All you have to do is practice. And look at the answer here. Is that 2 comma 3? I don't know. So let's calculate it. Go second calc. All right. Select intersect number 5. All right, and hit the enter button 3 times. Look at that, 2 comma 3. And that's all there is to it. So let's get a screenshot of this. Okay, let me see if I can do that. I forgot how to do this real quick, so I'm just going to do it the old-fashioned way of using the screenshot feature. Okay, and here we have it. There we go. So you can see that the graph on the calculator matches right here. It matches. Look at the bottom of the calculator. It says intersection. So right here. Okay. So why isn't it doing that? So it says intersection 2 comma 3, and that's right here, 2 comma 3 on the calculator. So you can verify that using the TI-84, any graphing calculator feature, even Desmos online. There's an online graphing calculator called Desmos. I haven't really shown it in class, but if you want to check it out, go online. It is free. All right, and it's probably the world's best free calculator online, so check it out. It's called Desmos. All right, pretty bitchin' stuff. Okay, all right, listen. This is a video, right? So if you need to, go ahead and go listen to any part of it. Again, get organized right here. Get your notes out. Check out the hyperlinks. Work hard, because only those who earn it will succeed. All right, God favors the prepared, you guys. So do your best, and I'll see you in my next lesson. This is Ainsworth. I'm out of here.